So we know that 5x to the fourth goes with 7x to the fourth. We know that 3x squared goes with 2x squared. And we know that the 1 at the end doesn't go with anything. But it's this minus sign that makes a big difference. There are several different ways that people like to set these up. I'm going to take you through each of them, and you decide how you want to do this. They all give you the same answer. One way that people look at this is they say, I'm doing 5x to the fourth minus 7x to the fourth. And 5 minus 7 is negative 2. Again, not changing the exponents. Then for the next piece, they say negative 3x squared minus 2x squared, which makes a negative 5x squared. Where this method becomes challenging is when we have something like this. At the very, very end, I have a constant plus 1, but there was nothing at the beginning to combine it with. And it is not always obvious what we would do. So here's what you would need to do. If there is no constant in this polynomial, what constant is actually there plus what? What number would be nothing to make me leave this completely blank? 0. If I add 0 at the end, it means nothing. So there's an invisible plus 0 here to go with my 1. But you have to remember it's 0 minus 1, which means it becomes a negative 1 in the final answer. Now, I do not suggest doing it this way, because there are a lot of mistakes that people tend to make when they don't do anything else. If you just try to remember every single time to stop in between and remember that you're subtracting whatever comes next, a lot of people make mistakes with this. So here's what I suggest. I could take the exact same problem, and what I would suggest doing instead is saying this minus sign in the middle. It means something. If it was a plus sign, it wouldn't mean anything. I could get rid of the parentheses and nothing would change. But with a minus sign here, there's actually something else going on. What if we said many, many times in this class, when you see parentheses in a problem, there's probably some amount of what? Jaime? Distributive property. So then you ask yourself, well, what's there to distribute? In front of here, there's nothing, which would be a positive 1. Over here, there's nothing, which means it should also be a 1. But with the minus sign in the middle, it means it's a negative 1. So what we're actually doing here is distributing a positive 1. Oops, there's nothing there. And distributing a negative 1. Now, if I do this, I end up with just one continuous stream of terms. Here's the benefit. If you identify that this minus sign is actually a negative 1 that I'm distributing, what you're doing is saying that this positive 7, if I multiply with a negative 1, is now minus 7. This plus 2x squared, if I distribute a negative 1, it becomes minus 2x squared. And this plus 1 becomes a minus 1. So now when I find my like terms, 5x to the fourth minus 7x to the fourth, I get negative 2x to the fourth. Negative 3x squared minus 2x squared, negative 5x squared. And I have this piece by itself, minus 1, but it's already written the way it's supposed to be. So the benefit here is that you get a little less confused with the signs if you've already distributed this. Now, there is a third way to do this that I'm actually not going to demonstrate because I do not think it's a very good method overall. But if you really, really like it, you can do it. Same thing we saw in our classwork problems, you could stack these. But if you stack them, you have to remember that everything being lined up is a subtraction problem, not an addition problem, even though sometimes you see plus signs. So my suggestion is this right here. Distribute the negative 1, and then all you have to do is find the pieces that go together and combine them, just like we were doing before. So really the only difference between adding and subtracting is distributing that negative 1 in the middle. Aside from that, they are the exact same thing, and it's all about combining like terms and don't change the exponents.